Recording in progress. Hello, good evening, the audience.
I can see it's filling up, Rainer.
Yes, there are quite a few people in the waiting room getting ready for our webinar on hydroponic grow.
Yeah. I guess we give them a few minutes before we kick off.
Yes, let's make sure that the late arrivers will not miss the beginning. So as a general rule, only Josh and I will be visible. All the other attendees, they can write down their questions, but they will not be visible.
And only for the first two slides. We don't want to distract from the great content of the presentation after all.
Oh, this is very nice that even at this late hour, we get so many people coming to our webinar.
Absolutely. Outside of office hours.
Well, we have a hobby as a topic, so it's most likely after office hours for most of them. And happy to be with all of you.
Okay. Oh, I can see a couple of Dosatron colleagues on the call. That's nice.
I think we should give it a little bit more time not to start on.
I think the velocity is still quite high, so let's give it maybe a minute or two longer.
Josh, I think it's only you being visible, and now that I speak, people do see me as well.
Yeah, the both of us. Okay, one more minute and then we'll kick off. Oh, more people dropping in. You can see our friends from Germany have just come into the chat. Somebody raised their hand. Okay, Rainer, what do you think? Time to kick off?
I think that let's begin. Josh,
Okay,
let's start.
let's start. Good evening, everybody. Welcome to the Dosatron webinar on optimizing your hydroponic grow, how to work less while maintaining crop quality. The focus of this session will be Dosatron's new Hobby System, which is a water-powered automated fertigation system perfectly suited for smaller applications. The purpose is to educate on where the system fits in and the benefits it offers to cultivators looking to save time on mixing nutrients so they can focus on their plants. We'll start with some introductions. My name is Josh Goodman-Levy. I'm the Global Business Development Manager for Dosatron, responsible for all hydroponic business outside North America. I've been with Dosatron for about 1.5 years, and prior to this, I worked in the medical cannabis sector as an operator, investor, and consultant. At Dosatron, I work closely with medical facilities, non-profit social clubs, nutrient companies, and of course, our hydroponic-focused distributors and retail partners. Rainer?
Yeah, my introduction is a bit shorter because, well, I am the technical expert in all irrigation questions. My role in Dosatron for more than 20 years now is to support our partners, customers, and distributors for any technical issues. And I'll be here to answer all your questions later on. Josh?
Thanks, Rainer. So we're going to talk for probably about 40 minutes through the content of this presentation, and then we'll open up the questions. So feel free to drop questions into the chat before or as they come to you. Thank you. So let's start with some frequently used terms. First of all, fertigation, the process of applying fertilizers or treatments through the irrigation system. This is essentially how we inject a chemistry into a water line. At the most rudimentary side of things, before fertigation, you'll be hand mixing nutrients, either pouring liquids or adding soluble salts to a day tank and mixing them manually. This promises to take up significant labor time, along with being subject to human error. Fertigation is really the jump to automation, where you introduce a mechanical or electric pump to accurately and repeatedly inject the needed concentration of the selected ingredient into the water line the moment the plant needs it. Stock tanks, highly concentrated fertilizer or chemical solutions the injectors pull from, can be both ready-to-use liquid or hand-mixed soluble fertilizers. So on this, I think that's fairly self-explanatory, but one question I get from end users quite a lot is, what is the maximum vertical distance the Dosatron can be installed above the stock tank? The answer is 4 meters. This is true both for the D15 doser that you see here on the left, and also for the other professional line dosers, be they the D3 or the D9 that you more commonly see in commercial applications. The next one, direct injection, plain water pumped through the irrigation system directly to irrigation at plants. This describes an application where you will have your water source running directly through the Dosatron system to the drippers and then your plants. Now, the reason you may want to run this sort of system is if space in your facility is scarce and you don't want to dedicate additional space to day tanks, which we'll discuss next. You'll still need room for the Dosatron mounted above the stock tank, which in direct injection applications you'll typically see in a corridor between grow rooms or within the grow room itself. Day tank, source water pumped through the irrigation system to the day tank for future irrigation events, with a secondary pump providing the ready-to-use solution to the irrigation system. Day tanks, or batch tanks as they are more commonly referred to in the US, the key word that I associate with using these tanks is redundancy. I'm sure that the operators on this call will all readily admit that no matter how dialed in your SOPs, running a facility is a process of continuous improvement, and inevitably things don't always go to plan. Having a day tank filled with ready-to-use nutrient solution provides the grower with options if there are problems with your emitters, piping, or water flow. Elements of the hobby multi-pump system. And we've also got some of our NDS units here as well. NDS standing for Nutrient Delivery System. The main system, which you can see here, comes with 4 doses and 5 unions. These injectors can handle a flow rate of 100 to 1,000 liters per hour and have injection ranges of 0.5 to 5 mils per liter. Next to the base system, you'll see an individual D15 expansion unit. These can be added to your hobby system array. You can have up to 10 units in a series before pressure loss may become an issue for nutrient blending. And these doses are also available to purchase via our distribution partners. Onto the nutrient delivery system components. To the right of the D15, you'll see the Hike Start. This is the hydroponic starter kit. This contains an inlet, 120 micron filter, an outlet to check water, and a pressure gauge. We then have a mixing chamber here. We recommend installing this after any unit which is injecting a chemistry that requires additional reaction time. So I'm thinking of things like silica, pH adjustment, and the like. Next to the mixing chamber, we've got the monitoring kit, which can be purchased either with or without a Blue Lab Guardian monitor. This will track pH, EC, and temperature, and along with coming with an included mixing chamber, includes a pressure gauge, holes for the probes for the Blue Lab, and an outlet. Lastly, we have a water hammer arrestor, which provides additional protection and security in case of unforeseen water surge caused by opening or closing the solenoid valves. Here we have a diagram basically showing you what a direct injection system looks like. We start on the left with our plain water source coming from our chosen water source. This travels through our proportional injectors, which each draw from the stock tanks below as the water travels through. The mechanism within the Dosatron is comparable to a syringe in that the precise injection of the chemistry will increase or decrease proportionally with the flow rate of the water, ensuring the consistent concentration of each ingredient. The solution will then travel through an inline filter, which you can see just to the left of the table, before moving on to the drip table and coming out through our emitters. Next, we have an example of a day tank system. This system is obviously quite similar, with the difference being in between the Dosatron system and the drip table, we have our day tank of ready-to-use nutrient solution. Day tanks come in many different sizes, and they're filled with our final solution, which can be drawn from on demand. In order to create the necessary flow to move the water from the day tank to the drippers, we will utilize a secondary booster pump, which is located just here next to the day tank. pH and EC monitoring can be conducted either inline or within the day tank itself. So we typically recommend using a day tank situation in a number of scenarios. Normally, if we want to use pulse irrigation, we'll use a day tank. So if we're adding small shots of between 30 or 45 seconds worth of solution, a day tank could come in handy. In addition, if we're operating outside of the flow range of any particular Dosatron system, you can also use a day tank. This is because we are using the Dosatron system to fill the day tank. And then after the day tank, we can use a booster pump to send the solution to the drippers at any flow that we require, be that below the minimum or above the maximum flow capacity of the system. Day tanks also provide additional opportunities to adjust the solution, i.e. you could heat the solution, you could provide additional in-tank agitation, or you could provide aeration through the use of a bubble stone. As I mentioned previously, day tanks really create redundancy through providing a ready-made solution that can be available on demand. So, automating fertigation process. When talking about automation, the first thing I like to mention is the differences between solenoid valves and manual ball valves. A solenoid valve is a 12 or 24 volt valve that can be triggered by an irrigation timer. We are essentially automating the process of turning a manual ball valve to open or stop the water flowing through the system. In a more sophisticated system, this could be automated further through the use of an irrigation controller. When we talk about irrigation timers, it's important to note when selecting a timer to pay attention to the number of start times allotted on a particular controller, and then the durations that they are able to go to. For instance, you may get 4 programs on a basic irrigation timer, and those 4 programs might have 4 start times. If you used every program, you'd have a total of 16 start times, which would enable you to have 16 irrigation events in a day. Duration also comes into consideration, where some of the more basic irrigation timers only allow you to go down to 1 minute of runtime. So just always be considerate, always ask those questions and do the research ahead of time before selecting a timer so that you get the most out of your, so you get the most suitable one for your chosen irrigation strategy. We also like to recommend using pressure compensating emitters. These emitters are very beneficial in providing an even distribution of your solution from an irrigation system to each plant. Because they are pressure compensating, they always have the same discharge, regardless of pressure variations in the line. They come in all different sizes and flow rates, usually measured in liters per hour. So there are a number of different ways to fill day tanks, starting with the last one, which is the most simple, manual ball valve, literally turning it on and off with your hand, watching it fill, turning it off when it's full. We can also use a differential float valve, which we've got at the top. This float valve will open and close depending on where the water level sits in the day tank. Typically, we like to drain the day tank to a low level and then fill it to a high solution level. This way, we are turning over our tank and using fresh solution every time we trigger a day tank fill event. We can also achieve this with a float switch that triggers a solenoid valve, which fills the day tank. Another thing we like to think about is hand watering from a pre-filled day tank using a watering wand. This can be done directly from a Dosatron system if the use of day tanks, solenoids, emitters, and a fill irrigation system is surplus to requirement. The point here is that we can still benefit from the automation, consistency, and accuracy of the Dosatron dosing technology in a hand watering scenario. So here are two examples, one of the solenoid valve process and one of the manual valve process. Prior to the drip table, in the first one, we can see the solenoid valve, which is triggered by some sort of irrigation controller, which will tell the valve to open for a set period of time. At the table, we have our pressure compensating emitters, which are feeding the plant with our mixed solution. In the manual valve situation, we have all of that, but without the automation of the solenoid valve. Day tank fill process. Here we have three different ways of filling the day tank. Again, starting with the one on the top right and the most simple, the manual ball valve fill process. Simply, we have the manual ball valve. As for the irrigation event shown previously, this is turned on and off by hand. The top left, we have the solenoid valve triggered by the float switch. First, we have the solenoid valve, this time triggered by a float switch. The float switch is placed in the day tank at a predetermined level, either low or high. As the nutrient solution level rises or falls, the float moves accordingly. The float switch is an internal mechanism that closes or opens a circuit based on the position of the float. At the bottom, we have the mechanical differential flow valve. In this situation, we have a low fill point and a high stop point. When the tank gets to that low level, it will fill until it reaches the high level. If you go for this option, it's important to check the product specifications of the float valve to ensure that it is compatible with the tank size that you are trying to fill, as most brands have a minimum tank size that they need to operate with. Water storage, treatment, and filtration. So clearly, the water source is a very important thing to identify before setting up a fertigation system. We can use RO water, reverse osmosis being a water purification process, or alternatively city or well water that can be filtered or treated to your requirements. Ultimately, the question is, where are we getting the water from and where is it being stored? To maintain good performance in the Dosatron, we do suggest treating or filtering the water, at least for large particulates, which may cause abrasion in the internal mechanism of the unit. In order to ensure we're feeding our plants good quality solution, we also want to be sure to remove excess heavy metals, impurities, and pathogens. And we can use dechlorinization, RO, or more basic filtration to help achieve the desired level of purity. If we do not have some type of water storage, if we do want to have some type of water storage, it's going to come in what we call a freshwater tank. Here we go through the filtration process. It is then piped to a holding tank appropriate for our consumption needs, i.e. how often do I want to refill this tank? How much water am I using through my irrigation system on a daily or weekly basis? And how much water do I need to hold to keep up with this demand? Following the water tank, we will need to utilize a booster pump in order to move the water through the fertigation system to the day tank or straight to the emitters if we are using a direct inject system. We call the booster tank after the water storage tank the primary pump, and the booster pump following the day tank the secondary pump. One important thing to note here is that we want to push the water through the Dosatron system, not pull it through. It is therefore critical not to place a booster pump after the Dosatron system without compensating pressure of the booster pump before it as well. Without this, you may experience siphoning, which is the uncontrolled intake of a stock solution. So we've got some maths coming up, but it's simple, so don't worry. Calculating flow rates. The first step is to identify the total flow rate requirement of the zone in question. We take the total number of emitters in the zone and multiply it by the drip rate of each emitter, typically measured in liters per hour. Let's look at this example. If you have 300 emitters, each running at 2 liters per hour, this means that the total flow rate requirement for the zone is 600 liters per hour. We can use this information to identify which Dosatron unit is appropriate for the application. In a few slides, we'll run through the operating specification of the hobby system, and we'll see that the injectors utilized have an operating flow range of 100 to 1,000 liters per hour. So they would work great in this example. Let's look at an example where we do not have an existing irrigation system, and we're looking to find how many and what size drippers we need in order to fit into the parameters of a Dosatron system. Please note that this is only relevant in a direct injection application. We first take the minimum flow rate of the system, which in the case of the hobby system is 100 liters per hour. We then take this number and divide it by the total number of plants in the zone. This gives us the minimum flow required per plant. So here we have 75 plants in the zone and want to find the minimum flow rate. We take the minimum flow rate of the system, which is 100 liters per hour, and divide it by the number of divide it by the number of plants, which equates to 1.33 liters per hour per plant. Using this information, we can ensure we have the right number of drippers with the appropriate drip rate to have the prerequisite minimum flow for the system. If you wanted to know the maximum flow rate tolerated by the system, we do the same equation, but instead take the maximum flow rate of the system and divide it by the number of plants in the zone. So rather than 100 liters per hour, we have 1,000 liters per hour, obviously in the case of the hobby system. So if we have 125 plants in the zone, this gives us an 8 liters per hour maximum flow per plant. So select the number of emitters and drip rate accordingly. Together with the minimum flow, these calculations are useful to us when selecting an appropriately sized booster pump in a day tank scenario. So here we have a number of different potential orientations, different ways that you can arrange the Dosatron on the wall. Typically, you'll see it moving left to right in a horizontal line, as you can see at the top. However, because the hobby system is really intended to be utilized in smaller environments where space is perhaps a limitation, there are creative ways that we can choose to orientate our system so as to take up less wall space. And this can be seen in these two examples here. So the U-shaped configuration and also the serpentine configuration. The important thing to note on this point is that regardless of the system design, you must ensure that the water flowing through the system flows in the direction of the inlet. Now, this is conveniently shown by an arrow that appears just above the injection stem of the unit. It's a little bit vague in this larger image of a unit on the left, but if you look at the smaller units, you should be able to see a light blue arrow above each injection stem. This arrow shows you the direction that the water needs to flow through the Dosatron. Okay. So here we have the product specifications of the D15 injector, which makes up the hobby system. The operating flow range is 100 to 1,000 liters per hour. In terms of pressure, the system functions within a range of 2.5 to 6 bar, again being something to consider when selecting a booster pump. Oh, sorry, we'll go back. The pipe connection size is 3/4 inch BSP on the inlet and outlet. Just to note, this is also true of all of the NDS components that we talked through previously, as well as our D3 professional line range. The dosing range of the D15 is 0.05 to 0.5%, which in milliliters per liter equates to 0.5 to 5 milliliters, perfectly suited for most liquid nutrient lines. The maximum temp the system tolerates is 40 degrees centigrade, which is something to consider for growers reliant on water stored in warmer climates. We've also below this got lots of data around the weight, height, and size dimensions of the system. Lastly, the system includes a mounting bracket, suction hose, weighted strainer, union connectors, and a quick start guide. So here we've got a zoom in of the injection stem. This shows you the interface and the units of measurement that are used on this unit. The two ranges for the D15 are milliliters per liter on one side and milliliters per gallon on the other, obviously mainly for our American friends. It is adjusted the same way as other Dosatron units, where you twist the injection sleeve to increase or decrease the injection setting accordingly. When you hit the setting you want, you can lock it in place with a locking ring. So, to close out the main part of the presentation before opening up the questions, we thought we would run through a couple of example configurations to demonstrate the flexibility of the system. First, we have the system set up to run the Athena Pro line. You'll immediately notice that there are 5 doses here. We've got the main base unit, and ahead of that, we've got a single individual doser followed by a mixing chamber. We'll talk through that now. So the series start with the starter kit, being the pressure gauge, inlet, outlet, filter. We then have the first individual doser. This is injecting Athena's Balance or Balance Pro ingredient. Athena recommend using this to increase pH. Because it contains potassium silica, they recommend that this is injected first in the series in order to avoid precipitation. As a pH adjuster, we recommend to follow this unit with an additional mixing chamber to give sufficient reaction time for the chemistry to be absorbed. We then have 4 doses injecting Grow or Bloom, Core or Fade, and Cleanse. And depending on your preferred EC, the first ingredient, Grow or Bloom, can require a higher concentration of up to 10 milliliters per liter or even above, which, as we now know, is above the 5 milliliter injection range maximum of an individual doser. So the workaround is to split the load. What this means is essentially running the ingredient through 2 doses simultaneously. We plug both suction hoses into the same stock tank and we double the injection capacity. Clearly, one thing to keep in mind is that in this scenario, the stock tank will empty twice as quickly. The last 2 ingredients, which are Core or Fade and then Cleanse, are within the injection range of a single unit, so it can be run through the last 2 doses of the system. Lastly, we finish up with the monitor kit, which includes this mixing chamber, and lastly, a water hammer arrestor. So on this configuration, we're running the Athena blended line, which is the liquid line. We're using 6 doses here because there are 6 ingredients to that line. And similar to the last slide, we use the mixing chamber after Balance or Balance Pro, and we have an additional mixing chamber as part of the monitoring kit. So the last thing I want to talk about before we open up for questions is, where does a freshwater bypass come in? and how is it achieved? So as you can see, we've simply diverted the water outside the Dosatron system via a T-fitting just here and have it come back into the piping after the system. This allows us to provide fresh water to the emitters for flush or for other types of cleaning. Now, this is arguably a particular consideration for hobby system users, as unlike the other Dosatron units that you may be familiar with, the D15 injectors do not come with a bypass switch on the top of each unit. Now, what this means is you can't turn on or off the ingredients on a per doser basis. What we can do to get around this, a cheaper and possibly slightly more messy solution to turning of particular ingredients, is that we can physically remove the injection hose from the stock tank. The Dosatron will continue to have water flowing through it, but it will no longer inject the ingredient. So at the end of this system, after the water hammer arrestor, we've also included a check valve. This will ensure that there is no flow of water from the fresh water bypass back through the Dosatron system. So that takes us to the end of the presentation. We've managed to get through that in half an hour, which is great. I think we can open up for questions. Raina, have you seen any questions? I haven't had a chance to look at them.
Yes, I have already two here. One is here, which errors may occur during installations, and I'd like to answer that in a brief fashion. As Josh mentioned during the presentation, it is very important to respect the flow, direction of flow through the unit. If you do respect that, it seems a bit ridiculous, but it happens that people put it in the wrong way and then wonder why the doser is not working. Water will pass through, but it will not be dosing. So please respect that. This is one of the most important things. And then, of course, the suction hose needs to be fitted correctly to the doser unit in order to make sure there is not air being drawn up, and underdosing would happen otherwise. And also, of course, please respect the hydraulic limits of the unit. So the minimum flow needs to be there, otherwise the unit will perform, but not with the accuracy you want to achieve. And also do not exceed the maximum flow rate, which will result in the mechanism of the unit getting damaged. So if this is like common sense, I would say, follow the instructions and the manual, but I know who reads the manual. Please do so. And yeah, then that's about it. Now, if you respect that, you will not have any errors.
Okay, good. Let's look, what other questions have we got here? How about organic ingredients?
Yes, organic ingredients, as long as they are liquid, they can be dosed without any troubles. Some organic fertilizers, they are a little bit viscous, sticky. I would say compared to like the motor oil you put in the engine of a car, well, combustion engine. That is about the viscosity these dosers can handle. So I think most of organic fertilizers are suitable. If you're thinking of like some real sticky stuff, then a pre-dilution might be necessary with an going of an increased dose rate. But so far, I have not encountered difficulties with organic-based fertilizers. I see a question here, hey, from Peru. That's great. Hello, Peru. Is there any way to automate the dosing ratio? Well, Dosatron is a mechanical device, and so to change the dose rate, you have to go there and change the setting of the unit. And like this, it is not automatable to adjust the dosing rate as like from a pilot. regarding the creation of the fertilizer solution, these adjustments are not very often necessary. So if you're feeding like the day tank or inline direct feeding, you don't change during the day. You change maybe 3 times during the crop cycle. And so you will adjust and then continue with that new adjustment. So I don't think in a Dosatron setup, this is something to be considered as necessary. And the experience for the many years we are around have shown that Dosatron is giving quite satisfaction. So no automated dosing change. You need to do it manually.
Here's another one. What are the differences and advantages of Dosatron proportional injection versus peristaltic or Venturi-based systems?
Oh, this is a great question, as these other injection methods are quite known in the world. So first of all, the peristaltic pump is injecting into the flow, and to render it proportionally, you would need like a water meter, then a controller piloting this peristaltic pump. And if you do have several ingredients that are necessary at the same time, so like the Dosatron, we have 3, 4, 5, or how many ever you need in series. These peristaltic pumps, they have to be recalibrated rather often, 2, 3 months time, to make sure that they are still performing as they should. And if you do not do that, then you will not have the recipe you want to achieve. You will get some dosing, but not the real results you want. So this is possible, but it needs more installation stuff and more control. As with the Dosatron, once you have set a certain recipe, this will be maintained, well, basically as long as you do not change the dosing setting, this result will be repeated. Regarding Venturi injectors, as the name says, this is an injector. And to render a simple injector proportional, which we want to have to maintain a constant level of nutrients in the water, the Venturi also needs to be piloted. You need a water meter and a sophisticated control system to pilot that Venturi on the suction side on and off. Possible, but again, more parts and more costs involved. So these other methods are possible, but well, please consider what you want to achieve and then choose the Dosatron.
We have another question here. What if we want to inject below the minimum rate of the unit, so below 0.5 milliliter in the case of the hobby system?
Yes, the hobby system is with this wide range from 0.5 to 5 milliliters per liter, covers, well, a lot, but not all. So if you actually do have the need to go below that 0.5 dosing, you need to pre-dilute your stock solution. So in order to have a less concentrated stock solution, and then the dose rate, if you, for example, dilute it with 1 part of water to 1 part of your fertilizer, you simply have half of the dosing setting, which is set at the Dosatron. And like this, it's a simple calculation how much you need to dilute the stock solution in order to achieve the very low dosing you want to.
That is clear. We've had a question, where can we buy the system and how much does it cost? So what I would suggest is, if you're interested in the hobby system, you can see my email here and Reiner's here as well. Please send us a mail with your specifications, the system that you're envisaging, where you're based. We can direct you to one of our in-country distribution partners who should be able to help you acquiring a system, but also installation and support on the ground.
And regarding whether this webinar will be available, yes, it will be. There's a recording, and we will send you a link so you can rewatch everything.
Absolutely. I'm just going through. Do we have any more questions here? What is the lifetime of the hobby system?
Good question. Depends on the use. So Dosatron is a mechanical device, and it is not designed to last a certain time, but to do many cycles. And so a Dosatron needs to do many millions of cycles without any major intervention. Just a standard like cleaning once a year or making sure everything is correctly fitted. And from experience with other dosatrons, the hobby system is quite new, so we do not have any long-term experience. But from our long-term, almost now 50 years experience in irrigation markets, we can, with confidence, assume several years of perfect performance without any trouble.
That's good. We've got a question here on live sort of systems. Do we have anything in the field so far? So we have a number of installations that are in various stages of completion. I think we've got one in Malta, which we can introduce you to, which looks great. We've also got another in Germany, which will be ready over the coming months. So yeah, similar to the where can I acquire the system, if you do want to see a complete system in real life, send me an email and we can send you the details of the people that have got it set up already. Rainer, what errors typically occur with the Dosatron system?
Well, as I'm answered, I would think that what I said previously, that installation-wise, if you do respect the manual and the arrow on the unit, there is not much which can go wrong otherwise. And so, well, normal or standard plumbing experience would be great. But also the system is very easy to assemble, so you don't need to be an expert plumber to do so. It's rather simple, straightforward, and the manual tells you how to do it. And I'm confident that who is capable of like fixing the tire of his bicycle can install Dosatron units as well.
Great.
I see another question, a comment for minimum dose, that the reservoir size to be filled, like here, the comment is like to fill a 1 liter reservoir. I don't think that a 1 liter reservoir would be sufficient to feed a decent grow. And so, yes, of course, we would not fill such small reservoirs. But I think in practical terms, reservoirs would have a size of, I don't know, 100, 200 liters minimum. Or you, as Josh explained, do it directly inline the Dosatron, feeding your plants through a drip system directly without any reservoir in between.
Yeah, Lewis, the expression over-engineered comes to mind in that system. Okay. We have a technical question. What is the Dosatron unit made of? What material is it made of, Rainer?
Yeah, we have several. It's made of plastic, completely plastic, and there are a few springs inside, which are stainless steel. So, from a chemical point of view, all fertilizers are compatible. Even acids for pH reduction or control are possible. The main body of the unit is made of polyacetal, and the motor is made of polyamide. These two go very well because the motor is gliding up and down in the body of the unit. So the friction is very important. And with these two materials, we have a very low friction, which results also in a very low wear. That's why the Dosatron maintains its performance for a very long time. So it's all made of special high-grade plastics to ensure a long lifetime.
And I guess sort of related to this, but essential, what kind of maintenance is required for the Dosatron units?
It's a very good question. And as we are working in, I would say, environment which is ideal for Dosatron use, we have a filtered water, sometimes even coming from reverse osmosis. And the fertilizers are very often liquid. So the main enemy for Dosatron, or the main cause for wear, is abrasive particles. And as long as there are no particles in the water or in the fertilizer, the wear on a Dosatron is very, very little. And so a yearly checkup would be nice to like replace maybe the plunger seal if that is hardening, depending on what kind of fertilizer you're using. And if you do install with inline monitoring, this also would give you instant alert if there's anything going wrong. But from experience, we know that if you do respect the filtration, you will have very little maintenance to do, and the parts are, well, readily available. That would be the seal on the dosing plunger, which is doing the actual dosing work, and maybe the non-return valve where you connect the suction hose. That might be a part to clean and replace in case of need, but that's about it.
And to touch on that, all of these parts are available via our distribution partners who also stock the system itself. So they'll be able to help with maintenance going forward. Right, I know we're 15 minutes early. We've rushed through this, but I think we've come to the end of the questions that at least I can see. Rainer, can you see any more that I've missed?
I just have to read. Louis had another one here. Yes, no, that's fine. That's fine. Thank you, Louis.
Yeah. I think we've covered everything. All I would say is, yes, this presentation will be recorded. It will be sent to everybody that attended after we finish the session. Please take a note of our contact details. We're available to answer any questions and also to direct you to stockists as well. I will be present at Spannabis this year, so please make sure to reach out to discuss Dosatron with me. Looking forward to that. And otherwise, I think we've covered everything that we wanted to cover on this call. So with that, Rainer, unless you disagree, I think we can draw this webinar to a close.
Yes, I think so. So very much all my well, I'm very thankful that all you joined. Excuse me, I'm a bit confused here. The webinar, as Josh said, will be recorded, and we are here to answer any questions. So please feel free to contact us, ideally via email. And thank you all. Nice evening to everybody.
Have a lovely evening. Thank you.